So in this example, we're given a function f of x, which is 9 over 1 minus 2x, and another function g of x, which is 1 over x. And we're asked to find the functions f composed with g of x, g composed with f of x, and the domain for each of those. So taking those one at a time. First of all, so the notation f circle g here of x means, and I'm going to switch to color coordinating these, this means f of g of x. So that's the first thing, is just understanding the definition. Now, let's see, I could replace g of x here with, well, what g of x is equal to, in this case 1 over x. Now I go to the rule for f, given by this equation here, but I make the input whatever I have in the parentheses. So what I mean there is I go to the rule for f, 9 over 1 minus 2. Now x is just a stand-in for whatever input you're given. So in this case, the input is 1 over x. So 9 over 1 minus 2x, right here, we need to insert 1 over x. Oh, and I see the glare. I'm going to pause this recording. All right, and I apologize. These are very low-tech videos that I make, but it's that's my shtick. All right, so anyway, replace x with 1 over x. Now, well, we could clean this up a little bit. So this is 9 over 1 minus 2 times 1 is 2 over 1 times x, so that's x. Now, at this point, we have found the composition of these two functions, which is the word for this operation. We do still need to simplify. Before you simplify, if we know that we're going to be asked about the domain, we should note that this expression right here is only defined if x does not equal 0. So we need to make a note, for the sake of our domain, that we should exclude 0 from the domain of this composite function. Because if x is 0, then our input is undefined, and so we can't go any further. All right, great. So we've got our unsimplified composite function here. We've made a note about the domain. Now we should simplify. So in order to simplify this complex fraction, I want to get rid of this x. You want to get rid of the denominators of the inner fractions. So in order to get rid of that x in the denominator, I can multiply the entire denominator, this outer fraction, times x, which is only legal if I do the same thing to the numerator. So I'm going to multiply by x in the numerator and the denominator. And let me get rid of this arrow so I can show you something else. If you distribute the x in the denominator, this becomes 9x over 1 times x, so that's x, minus 2 over x times x, so that's just 2. And here's your simplified composite function. So this is f composed with g of x. Now I'd like to compare that with the other composite function, g composed with f of x. And before I do that, it's just occurred to me, I should probably finish addressing the domain here. So we already said that 0 needs to be excluded, because that was going to make this denominator 0. Now that we've simplified, we should also note that x cannot equal 2. If x is equal to 2, then the denominator of our simplified composite function will be undefined. And so the domain is all values of x except for 0 and 2. Okay, now let me switch over to this other composite function that we're asked for in this problem, g composed with f. Same basic idea. Order matters with composition of functions. So over here, when we found f circle g of x, that was f of g of x. So other way around, g composed with f of x, this is g of f of x. So this time, it's the f of x that's going to get input into the g of x function instead of taking g and putting it into f. So this is, let's see, g of So I'll just replace the f of x with what f of x is equal to. 9 over 1 minus 2x. And so now, in order to evaluate g of 9 over 1 minus 2x, this now becomes our input. And we're going to take that input and insert it into the g of x function. So this becomes, the rule for g is 1 over x. And when you get to an x, you pause and say, okay, x is just a stand-in for whatever your input is in this particular problem. So in this case, the input is 9 over 1 minus 2x. We could make a note here before we go any further that we're going to have an issue with the domain if 1 minus 2x is equal to 0. 1 minus 2x cannot equal 0. So if I'm solving that, let's say we add 2x to both sides of that inequality. We'll have 1 does not equal 2x. Divide both sides by 2, so x cannot equal 1/2. If x is 1/2, that's going to make this denominator 0. Okay, so it's always nice to pause when you're about ready to simplify, which is where we are. We've put one function into the other function, now we just have to simplify. Pause before you do that and make a quick note about, okay, but I need to make sure x is not 1/2, so this denominator is not 0. Because once you simplify, you're not going to recognize that fact anymore. So now, in order to simplify this, I have lids everywhere, we want to get rid of, again, it's a fraction within a fraction, or maybe this is what you guys would be more likely to think of this problem in terms of, this is 1 divided by a fraction, so that's the same as 1 times the reciprocal. That might be what comes more naturally to you. And so this is equal to 1 minus 2x all over 9. So notice the difference. These are two different functions. The order matters with composite functions. Very last thing here. So now considering the domain of this function, there's no x in the denominator. So this expression here is defined for any value of x. So the only thing we're concerned about is we need this input function to be defined. So we need x to not equal 1/2. Other than that, once we look at the simplified function, there's no other issues to resolve. And so the domain in this case is just all x values not equal to 1/2.